Electrification of the economy. This is Cleveland Jones. You can reach more details about him accessing his LinkedIn page. And this is Paul Taylor. The same thing, you can go to the LinkedIn page and see details about Paul. Um, Let me show one slide only, please. Uh, uh, there are several initiatives in the world to electrify everything. People are saying that uh, instead of gasoline, instead of diesel, instead of cooking with gas inside homes, stoves, ovens. So the idea that we read every time, every day, is that everything will be electrified. So we can see in this picture from the generation to the consumption, everything electrified here. It's a very curious point. So and this is the question, and I would like to hear from Paul first and Cleveland just after. So, Paul, your impressions, your thoughts about electrification of the economy, please.
Uh, Electrification um, is very important right across, as you've shown it, and that was a very nice slide to see as an introduction, because I'm going to be concentrating on the end users of the electrical grid. Um, we are electrifying everything under the premise that we're going to be decarbonizing. But when you look at the consumers, and I'm not talking about consumers in just in their homes, I'm talking about offices, factories, manufacturing, they're all the end user. And I'm going to cover the two main topics are mass transportation and buildings. Now, the decarbonizing of transportation is more difficult than people think, because we've got to overcome many problems with decarbonizing. The internal combustion engine has ruled the roost for well over a century and will continue to rule the roost for at least 20 or 30 more years. But if we can convert our transportation, and I'm not talking just about personal cars, I'm talking about buses, trucks, shipping, airlines, for example, it has the potential to solve many problems. And in the major metropolitan areas of the world, it will reduce traffic congestion and pollution. And electrical vehicles, or EVs as I'll call them from now on, and they set about to change everything about how energy is consumed and supplied. And in fact, EVs can be considered to be being batteries on wheels, because one EV can provide enough electrical power to power a home for 3 days. So EVs could well be a mobile grid of the future. And as a report from the World Economic Forum states, by 2040, more than half of the new cars sold in the world will be EV, with Europe taking 70% of the market and China over 50%. There's no mention of other big populations like India, but I'm pretty sure they're going to have a big impact as well. Now, energy efficiency is key, whether you're talking of coal-fired, oil-fired, gas-fired, internal combustion engines. Energy efficiency is very, very important. And it's a major benefit with because of the decarbonization and emissions, because electric motors are 3 times more efficient than internal combustion engines. They're also more reliable because they have far fewer moving parts, far fewer components than internal combustion engines. And I'm not talking, when I say internal combustion engines, I'm not talking just about cars. I'm talking about every motor that's used throughout the manufacturing sector, steelworking, coal mining, whatever. It's so, and according to the US government, they estimate that electric motors require 40% less maintenance than internal combustion. So, but the biggest problem with EVs is their cost. We all know that they cost significantly more than buying a petrol or diesel car, or a truck, or a van, or a lorry. They are significantly more expensive. And that's going to remain, I believe, in my opinion, up until the point when manufacturing costs come down to the same as petrol engine or diesel cars or vehicles in the future. And as I said, reliability is not an issue because the electric motors, they have far fewer components and they require a lot less maintenance. But then we come to the topic of operating range. This is a very touchy subject at the moment because many of the car manufacturers, they've been advertising ranges that none of the consumer organizations have been able to substantiate. And usually what the consumer organizations have found is that they're about 2/3 of what's been advertised. And this is a big sticking point because consumers are looking at range, and range anxiety is a term that's coming out because people don't want to start a 250-mile journey thinking that they're only going to get a third of the way there before they have to recharge their car. Or when they do find that they need to charge the car, there's a huge queue of people already waiting to charge their vehicles. And so that brings in the next topic, which is the charging grid. When I drive the motorways or highways of the UK, I'm starting to see more charging points, but it's variable. Different cities have, like cities in Scotland, almost everywhere you can see charging points, even in public streets. Where I live in Wales, very few charging points exist except at supermarkets, supermarket car parks. So range anxiety is something that really is something that has to be addressed. I mean, different governments in different countries, they have all different strategies for taking on this charging network. And then we have the charging time. When you take your car to a petrol/gas station, a few minutes later, the tank is full, you've paid, off you go, and you resume your journey. With an EV, you can be looking anywhere from 20 minutes for a fast charge but limited range, up to a full charge, which can take more than a cup of coffee and possibly an afternoon sleep nap as well. So we'll move on to the next slide. And when I talk about buildings, I'm not talking about our homes, just our homes. I'm talking about all the offices, all the buildings in the manufacturing areas, everything. Every building consumes. And buildings are responsible for 10% of CO2 emissions globally. So the two major targets for buildings in electrification is space and water heating. Space heating, that can be addressed through the technology of heat pumps. Now, why are they targeting these two major areas? It's because of their over-reliance on oil and gas hookups to power them. So, like my fiance, she's got gas central heating. My own house is powered by heating oil. That is 99% of the world. So space heating or cooling, for those in the warmer climates, is a major target for electrification. And many municipalities now, they've initiated programs with strict building codes that prevent gas hookups in new constructions. But this program has created a huge political backlash from construction companies because they have to build in the cost of heat pump technology or whatever technology they're going to use to heat the space in the building. And then you've got mortgage lenders because they're going to have to lend more money so people can buy those houses, buildings, whatever. And then you've got the people themselves who are looking to buy or get onto the housing ladder, or they want to move up the housing ladder and they see these new homes, but they're more expensive because of the electrification technology that's been adopted into their building. But the biggest challenge, though, in the building industry is from the conversion of existing buildings. It costs a lot of money to convert them, and there are governments that offer subsidies for you to convert, but those subsidies vary not just from country to country, but also within the country, where you live within the country. What size house do you have? Where is it located? Those subsidies can vary, so it can be confusing, and also it can put you off actually going through that process. But then we have price and grid responsiveness. Now, these are two important topics because these are concepts related to energy management and smart grids, focusing on how consumers and systems respond to energy prices and grid conditions. Now, price responsiveness is the ability of the producing companies, the energy producing companies, to adjust the prices based on the demand. And this can be either the time of day or the type of business. And it's all basically trying to make as much money out of the energy as possible. It's a dynamic pricing model. So, for example, you could have critical peak pricing. So this is when everybody has come home from work, they're all plugging in their EVs, they're firing up the kitchen, they're firing up the air conditioning or the heating because they want the space to be warm or cool, and that creates huge demand at a particular time. Now, grid responsiveness, though, this involves adjusting the energy consumption or production in response to signals coming from the electricity grid, such as demand response. And they need to work with this because they want to maintain stability across the grid. And it's very crucial for maintaining grid reliability and efficiency. So if we can move to the next slide. So all of the above, as I've said, it can put a huge demand on the network. You've got all these people coming home, but even if they're going to the office, all those offices, all those factories, all those manufacturing plants, they're all consuming. But when people come home, you've got, it's like you've got an urban area with a few hundred cars coming in and you get traffic jams trying to enter those small areas. And it's the same with power consumption. There's a lot of power going to those areas, so that you need demand flexibility. Now, for example, software companies with those providing cloud data storage, they have taken action that can leverage some of the capabilities in this system, because they've got data centers that are incredibly massive and their power costs are also astronomical. So what they've done is that they can look at optimizing wholesale and retail energy markets to use peak demand based on electricity rates. They can shift consumption to those times when demand is low and energy prices are correspondingly low, and thus lowering their costs. And this is called curtailed electricity. And there are smart charging software platforms coming to the market that will manage the coordination of charging across a network, preventing both peaks and lower power congestion. Now, these are all challenges, but Henry Ford said about 120 years ago, he wanted everybody to own a car. And now everybody does own a car. 120 years ago, it was just the rich who had automobiles. And then we had Bill Gates and Steve Jobs saying everybody should have a computer. And now everybody does have a computer. 40 odd years ago, Motorola said we should be able to communicate with anybody, anywhere, at any time. And we got the mobile cellular phones. And companies like Ericsson, Nokia, and Motorola all got into that opportunity. So necessity is the mother of invention, and innovative people with imagination will find ways to overcome these obstacles and will probably make a lot of money from their creative solutions. The rest will continue to complain, protest, and believe they bigoted propaganda. But we are moving forward. Whether we like it or not, electrification is coming, and we will overcome those problems. We've done it for many different technologies throughout our history, and we will continue to do so. Thank you.
Cleveland, before you start your presentation, let me ask Paul if he understands that stoves will be electric soon. In
Stoves?
UK, yeah, stoves.
Well, my oven is electric. My hob or stove is electric already. They are far cheaper to install and hook up. Whereas if you've got gas, connecting to a gas supply can be very expensive because you have to dig up the road, the entrance into the house, and install gas pipes. Electrification is a lot cheaper and easier. If you're talking about stoves for heating, again, the cheapest way is you use coal or wood-fired stoves. But it's much easier and cheaper to plug in a stove.
Okay.
Right.
Great point.
Necessity is mother of invention, for sure.
Yeah, that's a good one. Yeah, it really is. Please, Cleveland Jones.
Yeah, Kavana, I wanted to look at some background. I put together two slides, next one, that show, for example, the total electric energy by country, the biggest ones, obviously China, US, and so on. Big electricity users, big populations. Some of these countries, like China, are already big and growing. Further down, we have others that are going to be growing very fast based on their population, not just on the trends to electrification, just based on population. We know that a lot of these countries will grow extremely, as we've touched in the past. Energy poverty is something that will lead to greater energy use, and particularly electricity. But this view is just an absolute, largest consumption, production of electricity. If you go to the next one, I think this is pertinent. Sure. Because per capita, now you see that countries that we didn't even expect, or at least I didn't even expect to be way at the top. These are not the largest countries, the most populous countries, developed countries, yes. But per capita use shows how far electricity use per person can go. So even the United States, down there at 12th, Saudi Arabia, which is electrifying a lot of things despite all its oil riches and so on, but United States at 12th. And if we imagine that the rest of the world could at least reach the level of electrification that the United States has, or some of these other countries, then electricity demand will be 2, 3, 4, multiple times, because this is the possibility, the maximum possibility of electrifying households, markets in general, businesses, industry, and so on. So the potential is enormous. That we know, and it's clear. And also the way that it's divided up in world regions. Sure, the developed world is shrinking, even though it has grown, but it's growing less fast. As the other regions in the world, certainly China grows. China assumes a greater share, but India is going to be next up, and some African countries and some Latin American countries. So this is a very dynamic graph. In the next 15, 20 years, this will again reverse itself, and China may not be as big, whereas the gray, the Africa, and the others might be much bigger, and the other Asias, and so on. So it's very important to keep in mind the potential of electrification for countries in terms of per capita demand. It is enormous. Now, it's not going to be reached very quickly because many of the most populous countries would require tremendous changes in order for that to occur. But we know that that's a path that can and will be reached. But in the meantime, I think one of the things that we have to focus on is, as we can see in the next slide, Kamaya, there are many challenges. And some of the challenges with electrifying things in the economy is that a lot of countries suffer from point sources, large generating sources like nuclear power plants, large coal plants, and distributed loads, because the loads are all over the place: factories, homes, commerce, industry, and so on. That requires conveying the electricity from where it's generated to other centers where it's consumed. And then we have a gigantic backlog of maintenance and new infrastructure that is needed in terms of energy transmission and distribution. I just mentioned transmission here. But I wanted to show maybe the other side of the coin, maybe the silver cloud. There are opportunities out there to make the existing grid structure, the infrastructure that's in place, multiply itself so that it can keep up with increasing electricity demand and production. Whereas, as it is now, we know that if we double electricity production, that doesn't help because the grid can't handle it. There are a lot of cases, as we've discussed, of alternative energies, wind farms producing electricity for nothing because they're not connected to the grid because the grid isn't ready or it isn't capable of taking in that energy. But, excuse me, a lot of these new startups are coming up with ideas that are just amazing. That superconducting cables and so on have been known for a long time. They were kind of esoteric things they use in labs. But nowadays, superconducting cables, which we call low temperature and high temperature. The low temperature are close there to helium. High temperature is not high temperature, but around 70 Kelvin, which is, nitrogen is enough to provide that. We have several countries that have long-range transmission over superconducting cables. These cables, as thin or thinner than a single electricity cable of a major transmission line, can transmit over 200 times the power that a conventional cable can do. Conventional cables, basically aluminum wire around a reinforced steel center so that it can be extended over large expanses. These are very inefficient. They heat up, they sag, they cause forest fires in the summer and so on. These are major problems. You can also change the current grids called reconductoring. This is a new word where you just take the cable and you substitute it for a new cable. You don't have to go to a superconducting cable. That is a amazing jump in capacity. But reconductoring is able to increase 40% or more the capacity of an existing line. And the problem with existing lines is you can't license new ones. It takes 10 years to license a large transmission line over long distances. So we have to seek solutions that will allow the grid to take the electricity that's produced and deliver it to where it's demanded. And there are solutions out there that point to this. Not simple. This is not a comprehensive solution base. I'm just pointing to examples that show that creativity, innovation, new technology are providing the answers. And I'm a great believer, as you know, in new technology providing answers. Give it an incentive, give it some time, throw some money at it, and yes, you will find solutions. Sure, superconducting cables are more expensive, but since they can convey 200 times the capacity of a normal cable, you see how much room we have to move in terms of, substituting an existing line or creating a new line with much simpler licensing. You can just bury a line under, a sidewalk as opposed to a high power line that you have to have right of way on each side. You can't have houses nearby, that kind of thing. Electromagnetic fields are a big problem. All of this taken care of. So this is a big part of it. The next thing, provided the next slide, there's an opposite problem in many situations where you have point loads. You have large cities with big demands or large industrial centers that are providing a large demand for electricity, or it could provide a large demand for electricity if a large plant, for example, a steel plant, were to convert to full electricity. That would be a point load. And in many cases, the electricity that's being generated, new electricity, is distributed sources. Wind farms, I don't know where. Solar farms, I don't know where. And a lot of other smaller hydro plants distributed along geographical appropriate places. They're not concentrated. So this again creates a slightly different problem. Sure, you still have to convey electricity, but now you are more focused on storage and control of the loads and the demands. And indeed, I think storage is a fantastic opportunity because there's so many sizes of storage for different situations, so many types of different storage of electricity and power in general that can be converted back to electricity if there is high efficiency in the conversion. Because a lot of times the problem is you have low efficiency in converting stored hydroelectric into electricity. Well, whereas that is actually a relatively efficient conversion if, for example, you have pumped storage, but many other alternatives are not efficient. Even batteries, you lose some, but you have to have that storage. And some of that storage have an additional benefit that's essential for controlling the grid, stability, maintaining frequency, maintaining variations in voltage. And then, for example, flywheel vertical storage. This is not just an instantaneous storage. It's okay for a couple minutes at least, but it's very important because it provides voltage control, which is essential for many uses that rely on good electricity from the grid, meaning that it doesn't vary up and down a lot. And even more important, the frequency, because whether it's 50 or 60 hertz, depending on the country, you want that to be 50 and 60, not 55, not 45, not 65, not 55. So this is essential to maintaining a grid that can handle the higher demand and the greater opportunities for generating new electricity, especially from alternative energies. So these, again, are areas where there is a silver lining. technology has come up with a lot of solutions. Storage solutions for wind and solar farms that can actually hold a couple days worth of generating capacity, because you could have a couple cloudy days or a couple days without wind. More than that may be problematical, but that is very important. That is beginning to be more common, because before storage was so impractical and expensive that it was just not available. Now we're beginning to see these solutions. Sand thermal storage. No one had thought of that. But this is a very mechanically conventional way of storing energy. You heat up the sand, and then you use that heat to provide generation. And when you have spare generation, you heat up the sand again. This is a very efficient conversion process. And certainly these flywheels, they're magnetically levitated. They have very low losses. They're hermetically sealed. They can continue spinning for days if you need. So this is very important in terms of providing, providing longer term storage. So the solutions are coming up. And I just want to say that, yes, we have big problems. But next slide, please. You see that just like Paul mentioned, in the next slide here, we have areas that indeed are difficult to electrify. You know, everybody talks about it. Steel, cement, petrochemicals, pulp and paper, glass, certainly heavy transport and air transport. But I put a couple in blue because, yes, steel is difficult to convert, but it is a major energy user. So if you were to have large generation from alternative sources, wind, solar farms, or others, or even a new nuclear plant nearby, and you want to electrify, you could, because basically the energy is to heat the iron and do all this processing to get the steel out. It's a major concentrated point use. And it is possible, and we have many electrified steel mills, and they have a competitive advantage in pricing because they can say they are green because they're powered by green electricity. So this is an area that was difficult conventionally to understand electrification, but now it's becoming more viable. The other is glass, for example. Same thing. It's just a question of heating. Heat a lot of the processes with electricity. If it's green electricity, you can also tout that your product is green. Now, the other thing is petrochemical plants. Sure, very difficult. Pulp and paper plants, very difficult. Yes, some of it is heat, but some of it is other things, and it's very volatile. Here, a process goes one way and then another way. But again, if it's heat, yes, you can use electricity for heat. Maybe not the most efficient, but that is a big part of it. And then, of course, cement kilns, tremendous users. The reason that may be much more difficult to convert to electricity is because they are wonderful installations to actually incinerate a lot of things that you want to get rid of. And if you have coal, you burn coal. If you have wood chips, you burn wood chips. If you have toxic chemicals that you want to incinerate, high temperatures, long duration from one end of the kiln to the other. So those are very conventional, strong heat users that will be very difficult to electrify. And then, of course, like Paul said, long range, heavy duty transportation over roads by trucks or rail or certainly air transport will be extremely difficult because of the logistics of placing electric panels or batteries or whatever. So maybe other sources, even hydrogen and so on, might be more appropriate, but certainly even they will be very difficult in terms of energy density. But we see a lot of problems, and I don't want to end with problems, but I want to show that these are industries that taken together, if we can make significant inroads in electrifying them, or some of them, we would make a big inroad in electrifying the economy. Because taken together, these industries are 20 or sometimes more percent of the energy use of major economies. So this is a good
Okay.
starting point if you want to
Correct.
make big advances in electrification. Sure, you can electrify a lot of
Yeah.
house heating and so on, like Paul said. But that is
Mhm.
a micro effort, very distributed, and will take a long time to reach everywhere.
Yep.
If you electrify big consumers, you can make a big dent in the whole process. I like to leave it at that.
Yeah. Before we go to the section of business opportunities for medium-sized and small-sized companies that we enjoy this part of the session today, uh, Cleveland, the investments required for electrification are huge, and then the
Yeah.
less wealthy countries are not prepared for that. They do not have priorities in electrification. They have other priorities. How do you see this
Okay,
challenge?
I want to disagree a little bit. When you talk a steel plant, the steel plant in Nigeria is not Nigeria that's going to finance it. It's some German company, some Canadian company that's going to finance a steel company in a third world country, and they can decide, hey, we will use power from a hydroelectric project to produce and power this steel plant. And if that's their decision, they will electrify a major point source consumer in a third world country. And we have seen that. Major projects, even here in Brazil, maybe not coming out of this third world country
So, so it's
category, but we've seen that.
not an issue for the country, but the companies, big companies that are working in the
Exactly.
not wealthy countries.
Yeah. Now, the companies will do it only if, in some cases, you can justify the additional investment for an electrified steel plant versus a conventional plant by the price of the steel you sell because it's green steel or something like that. So even if it's produced in Indonesia or somewhere else, if it is green steel because it is produced
Mm,
from a full
mm.
electrified plant and electricity is
But
green or clean,
where
then
does
they
money
can
come
command
from?
price difference.
Where does money come from?
Oh, from first world countries. Certainly, the Germans are investing in steel plants overseas, also in
Okay,
Germany, but I mean,
okay.
the steel plants that they're planning in Africa and Southeast Asia are modern, and they're along this line, and especially with electricity provided from, in most cases, hydroelectric projects, because these are countries that lend themselves to that. This is green electricity going directly to a large user
Okay.
that can
Okay.
produce at higher cost, but they're
Okay.
selling their
Clear.
product at higher cost.
I've got a point, Armando,
Sure.
and that is in a place called Port Talbot in South Wales. There's a huge, very old steelworks that's owned now by Tata, an Indian company, and they want to electrify the furnaces. The political backlash is quite horrendous because it's going to put a lot of people out of work, not just those working at the steel plant, but the supply of coal, for example. Coal miners are going to lose their job. Transport workers are going to lose their jobs. There's a lot of politics involved other than just money. And this needs to be also considered.
Yeah, Paul, when we say electrifying the steel industry, what I think you're right. What we really mean is that new capacity is more likely to be electrified capacity because this
Yeah.
conversion
Yeah.
Oh,
runs up
absolutely.
into the
Yeah,
Yeah.
same.
that's right.
You have an
Yeah.
established plant that's
Yeah.
providing 1,200 jobs. If it electrifies, it's going to provide 800 jobs. The coal industry is
Yeah.
going to lose
That's right.
jobs. So, yeah,
That's right.
that's a big problem.
That's right.
And
Mm.
maybe when the life cycle is over for that plant, we'll think about it. But new capacity is definitely being considered, not just for steel plants. I mentioned that
Yeah.
because that's well advanced. Um,
Uh-huh.
Glass, pulp and paper, and very, very difficult, the petrochemicals, because they have the
Yeah.
source, alternative sources.
Let's go to our last 5 minutes
Yeah.
of our podcast today because we agreed before to go to 45 minutes today. And I would like to ask Paul first the business opportunities he sees in his presentation issues, especially for end users. How are the opportunities for business investments and
I find that very difficult to answer because I haven't thought of any opportunities. I've got three very close friends who have EVs that they've taken for their job. They're mobile workers, and so they have electric vans. And all of them have said that they've put solar panels into their home, but if they haven't generated enough, those panels haven't generated enough electricity, they can plug their vehicle in, and the vehicle powers their homes. There has to be opportunity there. As I said, software companies have found ways of leveraging the curtailed electricity demand. But I'm sure there's somebody out there who's going to see something innovative and find ways of creating that opportunity for themselves.
Yeah, the opportunities are there because, like I said, the grids are so restricted that any of these solutions, like I said, this magic wall that I didn't even talk about, it's basically a monitoring system for the cables of
Yeah.
transmission lines. And in California, those fires that were started by cables sagging and so on, you could solve some of those problems and you could ramp up the amount of power that the lines carry up to the known maximum. This is
but
efficiency.
Cleveland, sorry to interrupt you. For medium and small size companies or investors, how, are there opportunities for them in terms of grid investments and the issues that you brought in your
No,
presentation?
yes. What Paul was saying, for example, the consumers, certainly heat pumps, that is fantastic until we substitute basically all the conventional air conditioners, individual air conditioners, convert to heat pumps. The potential is fantastic, not just for gutter quality heating and cooling, but for savings, efficiency, and certainly electrifying and reducing consumption. So the potential for new business is fantastic, but not just for the consumer. I focused on the bottlenecks of the actual electrification process because transmission and distribution are one of the biggest problems because the grids are so old all over the world, except maybe China has got a lot of new construction. This is a major problem for electrifying further electrification. So the bottleneck is the opportunity. When you see,
Yeah,
we
but
can't go any further because
okay,
now the bottleneck.
okay. See to me and see that I'm owner of a mid-sized company or a small company. How what can I do with my money? I have $100 to invest.
Well,
There
I
are a
could
lot of startups, lots.
I could suggest that people should start looking at wireless charging of EVs. You can put wireless chargers into the tarmac, into the surface of the road, and when you stop, you're going to be charging your vehicle.
Wow, challenging point. Very
I
interesting.
think the opportunities are more or less what I just mentioned some time ago. Bill Gates and his investment arm that is investing in, I don't know how many startups, I think it's close to 100. He identified exactly what we're talking about. Companies that are startups that are going to capitalize on the opportunities to provide solutions.
Yeah.
The
Okay, but
problems are there. Someone
okay,
has got a solution if you can identify it.
okay,
Now,
but give some examples for us, like Paul gave the example of wireless
besides heat
charging.
pumps,
What
I
do you
think
have for grid?
I think these storage systems that are short term,
Mhm.
both flywheel storage solutions and several companies involved in that, as well as big companies.
Uh-huh.
And someone says, well, if Siemens is focused on that, maybe that can become a big portion of their business too, because the solutions can be applied all over the world. And this is something that is not little niche. It's large. So the potential is there. I am focused on the bottlenecks in transmission and distribution, and in control equipment. A lot of it is conventional copper-based control equipment. Now we're going to different types of equipment. Those companies, and I think this is where maybe we can provide individual type answers. And I think it would be important to be able to do that to the interested parties. And I think I've done a little bit of that. But this is very valuable because what investors and investment banks can do.
I still have $100 and not decided to invest based on your speech.
Well, exactly. I mean, the names of tips for companies to buy stock in is not what we're going to do here. But the niches, I can
Okay.
buy. And certainly they're the ones that we've spoken about. And small niches when you start, but the potential problem is so big that they can grow into very
perfect.
big.
Let me suggest that next Tuesday, if you agree, of course, we do a podcast about business opportunities for middle and small size companies for the energy transition with examples and let's see a practical example we can bring.
I will give a few, not all.
You can sell the others.
Well, I'll be selling shares.
Will do.
Great people. Thank you so much. It was a great pleasure to meet you
Nice
today
to
on
meet you
this
guys.
podcast here. Have a great day.
Bye-bye.
Bye-bye.